Hello, welcome to this channel. In today's video, we will learn about a CRF, which is conditional random fields. So this would be a continuation to our NLP series, in which we have already covered NER and IOB labeling. Now it's CRF, which is a conditional random field. So what it is, let me define it for you. So in a simple definition, it is a sequence modeling algorithm and it is used for the entity recognition problem. So there is a named entity recognition that we have studied. There is an entity recognition problem that happens due to NER. So how we can tackle with the CRF, that we will discuss. Now coming to the named entity recognition, let me jump onto my Jupyter notebook. Herein you can see that I have one sequence with me. This is I ate an apple in the breakfast. So I have loaded it into a variable named as rock, and then I have tried to find the labels. As you can see, I ate an apple. The apple here is having a B, or that is the beginning of an organization, which definitely is not true here because this is not an organization apple in this particular sentence. So you could see that there is a sequence labeling problem that exists here. Let me give you another example, which is I ate, instead of an apple, let's say a mango. Try to run this and then try to run the labels for this. And now you can see that it is I ate mango in the breakfast, and mango represent is B of location, that is beginning of a location. So definitely it is not a location. Here as well, it is a fruit like we had in the last sentence, in the previous sentence. So definitely there is a sequence labeling problem that can happen with the named entity recognition, because we are using a predefined NER models, or we can say off the shelf tools using spaCy module, right? So in order to tackle such issue or a problem, one of the techniques is the conditional random fields. And as the name suggests, it is a random field which indicates a probability distribution, and that to a conditional one. So we can say that CRF is equal to custom NER tagging. Now after this, we are moving to the CRF architecture, the overview or a brief overview of its architecture. Now coming to the architecture, just like any of the ML problem, B starts with a training corpus or input, right? So first of all, we will have a training corpus here as an input. Let me So here we have a training corpus. Now as we have seen in the previous lectures of NER and IB, we have seen that we are dealing with sentences or statements, right? So here also the training corpus will be having a sentence or a statement with us, and the training corpus along with that will be having some feature functions. So what are some feature functions? Feature function task is to compute set of features. For example, like what is the word starting with, whether the word is starting with a capital letter, whether the word previous to the word that we are searching for is starting with a capital letter or not, what is it, a pronoun or it is a noun, what kind of a pause tag it is having. So such kind of set of features we can compute for feature functions. So as an input, we will be having the training corpus as well as the feature functions. After that, we will be going to the model training. Now, how we will be training the model is what is the conditional random field is all about. We will be assigning the initial weights to each of the feature function that we have defined here, right? So all of them will be defined with the initial weights, and iteratively we will be optimizing these weights and finding the scores for the combination of the IOB labels. So what we will be doing, first step is assigning the weights. I'm writing WTS as weights for each feature function and Fn as a function. So we will be assigning the weights for each feature function. So initial weights can be splitted equally, or we can have different weights for the feature function in the initial stage. That is completely optional. So this thing is what we are doing in order to get the optimum model. Then after assigning the initial weights for the feature function, we are iteratively optimizing the weights. And finding out the scores for each IOB tags, beginning, outside and inside. So this we are doing for the model training. And then eventually we will train the model with the weight such that the score of the correct IOB tag sequence has the highest score. So the overall architecture of CRF is like this, wherein the highest score for the IOB tags is what we can obtain. And that would be the correct IOB tags for the given input sentences or the training corpus. Such that, this is a such that symbol, score of correct IOB tag sequence has the highest score. So this is the theory part for the CRF architecture and the CRF, what it defines and what is the architecture and the overview of that. And why it is a sequence modeling algorithm and how it can resolve the entity recognition problem. We will see that we have seen the problem, right, in the NER sentences that we have seen, like I ate mango in the breakfast. So herein the mango is definitely not a location, right? So this is one of a sequence labeling problem that CRF is supposed to resolve. And about the Python demo, we would be doing that in the next session.